Okay, welcome again to this second part of this afternoon session. We are going to start now with Philipp Henkel's presentation, which is implementing Günter Steinke, sorry for the bad pronunciation, arcade in Csound. Please.
Thank you very much, and also thank you to all the people who are organizing this and who are coming. I think it's a very good opportunity for everybody who is like programming or working with Csound to show what they are doing and show what's really possible with this powerful language. So I'm actually speaking here on behalf of the students of composition of the University of Music, Drama and Media in Hannover. And in our composition studies, we, like especially in electronic composition, we are trying to get really inside different programming language, and we mainly also use Csound for realizing our electronic pieces. I can kind of give you a backstory here about our implementation of Arcade, the famous piece by Günter Steinke for solo cello and live electronics. I think it was connected to somehow connected to an organization or a concert that was organized in the Hochschule, where we wanted to perform Günter Steinke's Arcade piece. And this piece was originally written, composed and realized in the early 90s, like 92. And what he used were like these big hardware machines during that time for different kind of sound effects and procedures that he used in the live electronics. And after that, we had a couple of implementations of the original electronics, or at least trying to mimic the original electronics in other programming languages like Max MSP or Pure Data. And we wanted to do that, and we felt that I mean, it's interesting the way it was implemented in the other programming languages, but we tried maybe what would a native Csound implementation of the electronics of this very complex piece would look like. And I mean, could we even make perhaps a better implementation of the piece, of the electronics of the piece? And I mean, just to give you some abstract about the piece, it was written in 92, it was premiered in Donaueschingen in the music festival, in this kind of big music festival in the south of Germany. And like I already mentioned, it was, I mean, Günter Steinke worked at the time in the SWR Experimentalstudio in Freiburg, which I mean, that studio helped him kind of to realize all the compositional ideas and the sonic ideas that he imagined from the piece. First of all, like I said, during that time, he had to use very big, like kind of like clunky and somehow big hardware devices, which are I think very good devices, but I mean, the problem is with these devices is that you need, basically, they take up lots of room, you have to pay lots of costs for transport and stuff, and with the evolution of like things like this, like that, it's very easy to just program the electronic procedures inside a small laptop and run them in a powerful programming language like Csound. Made it like, I mean, I would say maybe made a realization that used the hardware devices a bit old-fashioned. So we concentrated on recreating not so much the sound of these particular devices, like I just like I showed you here with the Publison Infernal, but we looked like, okay, what can we do with this wide array of functionality that Csound gives us? I mean, just thinking about the plenty opcodes, like filter opcodes that we get in Csound. I mean, how can we use them to kind of realize the piece for us in our native Csound environment. And Steinke for the piece used a large amount of devices. He had a pretty complex filter bank. He used pitch shifters, harmonizers. Then he used like delay and reverb. So he had many devices that he needed to somehow control and sync with each other. He did that by using a so-called crossbar switch. In the score, you will always read the name Koppelfeld, which is basically just German for crossbar switch. And so this made it very convenient to at least control the different devices, separate devices that he used together to realize the piece. But the problem is that, in a fairly complex piece like Arcade by Steinke, problems are, it's always likely that problems will occur in such a thing. And also, if I remember correctly, Günter Steinke also taught us that switching the modules inside them were also sometimes like, a bit risky. Sometimes it wouldn't work, and I don't know, it probably makes the realization of a piece like this way harder. And so for our implementation, we basically didn't want it to try to copy the other implementations, like the pure data one, which is very fine. The German composer Orm Findal did it based on the Max MSP patch from 2000, which I think Günter Steinke worked together with the guys who were doing it, or at least was a bit related to this patch. We really wanted to start from the ground up. Günter Steinke gave us in the score a pretty good documentation of what the different devices are doing in a particular spot in the piece, and it was actually kind of very convenient to see what was happening. So this made starting our implementation actually very quick, so we could have a general idea what we wanted to do. One thing, though, I think one of the main things we had to ask were how do we get together with connecting all of these different modules in a way that is basically the way that Steinke's intention was and the way he did it in the premiere of the piece in Donaueschingen. So we had to create kind of like we had to create a matrix basically to emulate the function of the Koppelfeld, of the crossbar switch. Here's just a small example from the code of our realization how we basically did it. It's important to mention that also, like the Max MSP has a native matrix object in it, and like some versions of pure data, not the vanilla version, but the Linux version of PD, this extended version, has, I think, a matrix object. So, due to their graphical nature, it's quite convenient, but it was fairly easy for us to come up with just coding the entire thing. We later used widgets, which I will show, to kind of monitor the things that will happen in the matrix. And the key is, of course, to use global variables. So concerning one important aspect of automating electronic procedures in this piece and also in the concert were like the cues. The original score had cues inside. We ended up changing a bit of the cues for our Csound version where it made sense. So, I think it's, Günter Steinke gave the opportunity that there might be a possibility that he renews the score concerning to the Csound cues that we have used. I think it's very likely that he will do it because also he himself said that his score has a fair amount of mistakes or errors in it, which I mean are likely to happen in a handwritten score like this, and especially when the piece is as complex. And so the cues, I mean, we basically use them for thinking procedures, like for example micro gestures. I call them micro gestures. What I actually mean is just like fade ins and fade outs on certain points of the piece, or like transitions to certain parameters, like for example if the harmonizer switching from this frequency to that. So we basically automated them with the cues, so we just had to press them and then it basically did it automatically, what before in the original version had to be done manually, which I mean is kind of risky, I would say. And I mean, one important aspect of doing all this and doing all this in a convenient way, I mean, I haven't yet mentioned that we have used, for our implementation, we have used the Csound front end, Csound Qt, which allowed us to very easily create widgets that synced with our actions that we use. I mean, we use MIDI controllers, and so we easily could like monitor our actions in Csound Qt with the widgets, and also could see like as you see, I mean, you see input, output, and stuff like that, and also like if you see like the vertical line there with the quadrat squares. I mean, this is basically like just this is the monitor for our matrix. I mean, to kind of see like what is going on, like which device is now active and which not. And yeah, I mean, I think one of the benefits of the widgets inside Csound Qt and was that actually we could create a pretty easy to use program for the arcade piece. I mean, I can mention it now that Günter Steinke was very happy actually with our realization of his piece. He said it's probably until now it's for him the definitive realization or implementation of the original electronics. And I mean, the good thing is that, I mean, it's a small file, you can share it with everybody, and I don't think you have to be quite, I mean, you don't need to know too much of Csound to just basically use it for a concert, for example. So it gives actually the opportunity that it's for like that it's been used more, the piece with the Csound patch. I mean, I want to talk a bit about why I think our implementation is so important. I mean, it sounds a bit high that I say the importance of our implementation. I just mean like the importance in general for the piece, and why I do think for this piece it's important, and also maybe for future developments in our studies, but also like in general for Csound. It's like we were the first implementation of this piece that was, like I often mentioned now, very truthful to the original plan of the electronics. In his score, the Max MSP and Pure Data implementation, they haven't used like the original complex configuration for the filter banks. They have used, I mean, kind of like they used FFT to kind of create the similar effect with the filter banks, but we have used like the original configuration, like how they are written down in the score. Like I said, it became like the definitive version of the piece, and it's likely that Günter Steinke will also like use this version now for maybe later releases, like of the score, let's say. And yeah, it was for our studies. I mean, you have to see we are all students of composition, and you know, we try to get into programming, and it was very interesting for us to to work with a piece which is not, first of all, not our piece, not my piece, not pieces of my colleagues, but to kind of be very truthful to the piece. It's kind of it's a bit like interpretation if you're playing a music instrument, but also thinking more like in general, like if you see, for example, I have mentioned we haven't used the PD version or the Max MSP version to kind of translate them to Csound. We wanted to really do a Csound native implementation, and for us it was interesting to kind of look into the functionality of Csound, and also like the thing with Csound is it has such a wide array of opcodes that one can use similar opcodes, and it forced us very much to try them all out and listen very carefully what is the intention of the piece. Like can we kind of get an idea how the piece should sound, like let's say what filter opcode is maybe more truthful to the original realization of the piece and what might not be appropriate for it. So it was also like kind of very much a hearing listening thing. And also, I mean, for us as students, probably very interesting was to maybe not even be too fixed upon the already existing opcodes, but also to try to create user-defined opcodes. Like we created one user-defined opcode just for the widgets, where it shows us like when we are over 0 dB, like when it starts to clip and stuff, and specifically for the matrix, we created user-defined opcodes. And I mean, this is quite interesting, because with user-defined opcodes and the possibility to use user-defined opcodes, but also building upon like the already existing opcodes, which are very sophisticated, we can basically very much customize the functionality to our likings and to the needs of a piece and the needs of different aesthetics. Yeah, this was basically my short report or lecture, I don't know, of our work with Csound. I think it's something for us very interesting for the future, maybe to tackle other pieces. I mean, there is a wide array of pieces, like from the time where it wasn't so convenient to just have a laptop and realize the electronics in the laptop, that one can try to implement in a programming language like Csound. And yeah, we saw yesterday in the concert also the possibilities of like recreating analog instruments in Csound, and I think it's not only limited to that. It's all we can, like I said, with pieces that were built like in the analog age, we can really look how we can create like a native version for it, not only like trying to emulate the analog system within it. So thank you very much for listening. And